Next, we are going to be talking about some of the specifics involving what are called expressions and values, okay? It's this tutorial here. Again, I'm going to put this on the site here. So, talk about this notion of a value. There's many places within AnyLogic where AnyLogic is asking you for this thing we call a value. And values, the term value is so overloaded. In different contexts, it means very different things. You know, we talk about, the values behind certain policies, expressed in certain policies. We talk about the value of money. We talk about the value of delivered by healthcare. But when we're talking about value for software, when we're talking about value for a programming language, we're talking about something like a number or a character or a value true or false. We may also be talking about a reference to an object, a thing like a person. We may be talking, I have a reference to a person. I have a reference to a string that says, in fact, exclamation point. So value is a single quantity. It can't be further evaluated. And we insert them in AnyLogic all the time. So here, for example, the timeout. This is a value. It's performing a computation to calculate a value, a number that's going to be used. In this case, the unit of the model is years. And so that number is going to be expressed in years, okay? Let's continue on discussing here. Additional places values come in. You will have seen them in assigning values to parameters. So, for example, when we have here the population, we have these values which are being used for the sexes and the ethnicities and the birth times, etc. A value is actually being calculated for each of these. A value could also be specified here with a simple by simply saying sex.male. The sexes are male. For something like the birth time, this is another value. You could say 10. But here we're calculating a value. We're taking 0 minus a draw from a uniform distribution between 0 and 80. That gives us a number. We subtract it from 0. We get a value as a result. So values are these quantities that cannot be further evaluated. They're specific quantities that can then be used, printed out, that are as specific as possible. So integers, 2 and minus 10, floating point values, 2.5, 1.0, characters, A and B, Boolean, true or false, references to objects. This last one is one we're going to talk about quite a bit to really give a sense of what that means. So much of AnyLogic snippets that you're inserting are what are called expressions. I like to call them formulas. And they're exactly the same sort of thing you insert in Excel. So in Excel, you say this value of this cell, notice I say value. The value of this cell will be the value of that cell minus the value of this other cell. Or the value of this cell will be this one divided by the value of this one divided by the value of that one. Those are formulas we insert into Excel, and we have exactly the same sort of things in AnyLogic. We call them expressions in Java. They're called an expression. But it really boils down to a formula. And what's the job of that formula? What's the job of that expression? It's to compute a value. Okay? For years, you've probably been writing expressions. Back to whatever it is, 7th grade when you were doing algebra. You were writing expressions that denoted values. A divided by A plus B. Right? So here are some examples of expressions. 2 times 5. 2 divided by 5, this being integer division. How many times does 5 go into 2? 1.0 divided by 3. A plus B times C. These are all expressions. A greater than B. This dot get connected agent of I dot name. We're going to learn to parse these things, but this is also an expression. It's going to chunk through it, evaluate each piece, and return a value. What's the value going to be? It's a reference to a string that's denoting someone's name. The string's going to say Joe or something like that. Okay, so it goes through this formula, it computes it, calculates it, and it produces a value. And we've been inserting those willy-nilly into these models. These are all expressions here into the model. These are all expressions. This is an expression, gives the value of some formula. Down here in the simulation, in the experiment, these are all expressions here. They're actually values directly. They're literals, we call them. They're expressions that happen to be values. But we use these things throughout our models. Wherever we insert a timeout, we insert a rate, we insert that a message must equal such and such. These are values. These are expressions we're inserting. Sometimes they're simple values. So all simple values, these literals, are expressions, but in many cases we give it a formula. We give it an expression to calculate that's more complex. Okay. So generally, in most places, AnyLogic wants a value. We give it an expression. It'll be happy because it's Java code. So here's common expressions. I want to talk about a couple of them. One is this dereferencing expression. You've seen this a lot, and you've tolerated it. I can't believe in some ways that you've tolerated it, that you haven't stormed out and say, what the heck is that? A dot B. What's this dot? Okay. Here, A is referring to some object, and we're saying, okay, object, maybe it's a reference to a person. And maybe B is something like the name of a field, their sex. So we're saying, hey, you, Joe, give me your sex. Tell me your sex. Tell me your ethnicity. So this might be A as a reference to Joe, and we say, give me your ethnicity, okay? And it will give us information on their ethnicity. Give me your income, A dot income. A is a reference to Joe, and we say, give me your income. Think about in AnyLogic, you have here associated with each population. Let's close this. I don't want to confuse you. I don't want to look at that. Okay, here we have our population, and we associate with the population certain statistics. Oh, we didn't assign it for this model, but we have other models which we have built. Let me go load one of them in. Here we go. This is our model from this morning. Here we go. We had a population, and here we had this sort of stuff, right? This is exactly the sort of syntax I'm talking about. Item dot get connections number. Or you could do item, we saw yesterday, something like if we want to mean income, right? We could do average over item dot income, right? We're asking for the income of each successive person in the population. Each person is going to be called item in turn, and we're going to take the average over those. So we're going to be first referring to Joe, and we're going to take his income, and then we're going to take Mary's income, and Sue's income, and John's income, and we're going to average them. So, okay, so this is item.income. That's an example of this sort of dereferencing expression. This A is a reference to something. Joe, Sue, Mary. B is a field of that, or it's a method that I call, like get connections number. Okay.
That's a little question.
Sure.
So in that situation,
yeah.
If you have here's this general thing and then dot more specific thing, right?
Yeah.
Is it possible to think of that as like a table? Is it possible to say, can I see what else is there? Any way I can tell AnyLogic say, I forgot what possible options.
Oh yeah.
Other side of that.
Most emphatically, you could do.
Okay.
Yeah, you could do control space, and this will tell you all so-called fields up here. These are all the sort of pieces, the characteristics, the properties of that person. For example, they have a color. They have some connections associated with them. They have a state chart. A state chart associated with them. Those are all the things inside of them the pieces of data, the pieces of information that they maintain. And and they have a reference to main. They have a reference, remember, this dot main dot, yeah. But then they also have things you can call on them. These are their methods. This is why it's object-oriented. They sort of bundle up their properties, the data associated with them, the information, together with the things that their ability to do things. So you could ask them, get your population associated with it. You could ask, you could ask them about the agents within a range of them, or you could ask them to connect to another agent, or you could ask them to deliver things to other agents inside of them, etc. So there's all these things we could ask it to do, including ask them to get their connections number. We could say, hey, John, return your connections number. Return your number of connections. And it would say, yes, sir, or yes, ma'am. I'm going to return my connections number. I'm going to return the number of connections I have. So here, saying item, referring, say, to John, referring to Mary, referring to Sam in turn, that dot, we can think of this as sort of their set of information or capabilities that they have, their set of things that they can do for us, as indicated by these methods. There, the method is calculating something or changing something, like connecting them to another agent. Does that make sense? Okay. So, question back there. Yeah.
So, between using item and this and self,
yeah.
We're in a situation where we're trying to sort out which one of these am I supposed to use.
Good.
You generally use that list of methods available to help you kind of knowing, okay, this is what I want to do, and that list to have you in which one you're...
This is true, but I also provided you with a little, you could call it a cheat sheet. I mean, it's a little a two-pager, which sort of says if you need to do this, use that for this thing. And that may be useful. But another way in which it's told to you is if you actually click over here, it'll actually tell you hints. So here it'll say use item, and it may sound a bit mysterious, but item is the embedded object. In other words, it's a thing in the population. AnyLogic is not, it's hard to build software that's really, really intelligent sometimes. And here it knows there's a population, but it doesn't pay, in its suggestions, it doesn't pay a lot of attention to its population of what. So really, and ideally, it would say use name to be the person, or the person, but it doesn't know how to sort of say that. After all, it could be not a person, but a bat, or a deer, or a car, right? A doctor. So here it's just saying the embedded object. But this is a hint that we have this item thing available to us. We virtually always have this. It's the current thing that's executing. If you're in Maine, this is Maine. It refers to Maine. If you're in a person, it refers to the person. If you're in a deer, you're executing a state chart for a deer, go get some water. It's referring to that particular deer. Okay? Always have this item and self, things like that. Those are things that occur in very specialized circumstances. Item you encounter a lot because it's in this commonly used statistics thing. And here, most of the time, AnyLogic is pretty darn good about giving these little light bulbs to tell you what you're allowed to use. Is that helpful? Yeah. But yes, you can actually, after this, you can find out what's going on here. Now, there are other ways of doing it that I don't recommend, but there are other ways of getting information about what's going on, and we're going to see them later, okay? And once we've gone through a little bit of understanding of Java, okay? Okay. Here we have, we're interacting a lot with this kind of dereferencing method that we've seen here. Okay, this dereferencing. We've seen this ternary operator. This is the type of expression. Where did we see that before? Anyone remember? Yeah, we're saying like if this certain thing is true, like if I'm in this state, make me red, otherwise green, for example. Or we say if I'm male, use this income distribution, otherwise use that income distribution. This is kind of like, you can kind of think of it as like in Excel, we have, I think it's called an if formula. So we say, if the certain thing is true, return this, otherwise return that in a formula, just like that. If predicate is true, predicate might be, if item.income is greater than $18,000, then we could say make them red, otherwise, or make them green, otherwise red, something like that. Does that make sense? Sort of a choice between these two things after the question mark, depending on the value before the question mark, depending whether it's true or false.
So let me find this in SVB, it's an L sign.
It's precisely the same. Precisely the same. It's different than a if statement, which is telling do this thing, execute these commands if this thing is true, otherwise do these other commands. Here we're calculating a value. It's an expression. Yep.
I've noticed that sometimes I have to interleave those, like I have hierarchies of
That's true.
those, and yeah, I know, it's really ugly. And the question is there a better way other than a function?
There's a better function. Go to function. Go to function. And by the end of this time, those who are still with us, I don't mean living, I mean, the boot camp isn't that bad. What I mean is those that are still attending these sessions, we'll learn about how to do functions to really clean things up. Really clean things up. It's horrible. I really dislike. I've written hundreds of thousands of lines of code in my life. I may die having written a million lines of code or something. I mean, huge amounts, both commercially and academia. And I really dislike looking at complicated code. It's confusing. I've been up too many nights wrestling with complicated code, and it just gives headaches. You want your code to be very clean. You want your Java to be very simple, easy to understand, well-named, so it's transparent. And nesting things deeply, it's for the birds. You will find, I should tell you this, and I should warn you, if any of you are going to partner with people who know Java, say for models, I think that's a really good thing. Just like an epidemiologist can partner with biostatisticians for those tough questions, partnering with someone who knows some Java for the tough times is a good thing. But just be aware there's different types of computer scientists. And there's some that know Java that are really good software engineers and really pride themselves in clean, maintainable code. And then there are some people who take delight in having really obscure things to strut their stuff. I've met programmers who show me things like, take a look at that. I bet you're not going to be able to figure out what that does. Horrible things. And so you want to maintain it really cleanly, and functions are the key part of that. Once you have functions, you can do lots of things very cleanly, because you give them nice names, put them in there instead of long expressions. It's a thing of beauty. Okay. You can tell I care about this. Yeah. Okay. So moving right along, another type of expression that we'll be learning more about tomorrow is things that actually change state. Okay. So like A equals B is an expression. You assign one thing to another. It actually is an expression. It returns the value that it assigns. But it's best not to do it. If possible, it's not best not to use it as an expression. It's best to use it just at a statement context. Change this thing. But you saw me do this today. Next ID plus plus. Do you remember that? Oh, it gave me the willies. I don't like to do it, especially in front of a group of people. It gives me the willies because there's a lot of things going on then. You're both computing the value and you're changing something. But sometimes it's the least bad way to do it. And that's what it was today. And so I said next ID plus plus. What this does is it increments it by 1, gives us the current value and increments it by 1. Okay? Okay, let's talk about these things. So there's additional things. Like if you want to say if someone is of this sex and their age is greater than 13 and their age is less than 45, say for a guard of a fertility state chart, you could, if you wanted to put those conditions in place based on age and sex, you could do it by stringing things together with this. It just means this has to be true and that has to be true. So X is greater than 0 and X is less than 500. There's also a thing, this operator, it's a logical not. It's not the case. We try to avoid these because thinking about nots gets really confusing to people. It ties them up in knots sometimes. It actually is, it has been shown in studies to cause bugs. If you use too many of these, people get confused. It's trouble reasoning. So we try to avoid those, using them too much. But you can use them. Here's another one, A of 20. We'll see this a little bit. What that means is sort of the 21st element of this array. So A is a vector. You could think of it as a vector. Starts with 0 element, and that's the first and second, and this is the 21st. Okay. And then here's an expression, a function call. We could say random true of 0.5. That's an expression, and it returns a value, true or false, based on a coin flip. Or you can say string A plus string B. You'll see me use this occasionally during the boot camp. And here we're going to put these two strings together. We so-called concatenate them. So maybe this is, this is boot and this is camp, the strings, and it turns it into boot camp. Right? Okay. Hate Java. Hate Java, right? So let's talk about reading these expressions. You'll have seen me do things that I think are quite, they give me the willies. I don't like doing this a lot. I like putting things in functions that have nice names, but occasionally you'll see me string together, like these sort of things. You think I like writing things like that? It's a lot going on, but let's learn how to read them. They're not too bad if you know how to read them. There's a lot going on there, and I know it's a bit overload to look at it. It's not very good for me either. I like to have it in small pieces. But look, this is what it is. Okay, so we have a reference to a person. Person is John. Mary. And we're going to ask for their state chart, the state chart associated with them. Okay? So they have a state chart inside, and it's going to get that back. It's actually a reference to a state chart now, to their state chart, their infection state chart. Okay, we have a reference to a state chart. Now we have a reference to it, and we can ask it questions. We say, hey, state chart, tell me, is this certain state active? And this person not infected means infective with respect to the person class. It's with sort of infectivity with respect to persons. And we'll talk about that a little bit later, what this really means. But if we have time. But here we're giving it a value saying, are you in this state? And who are we asking? We're actually in the infection state chart. So the way you've got to read this is, you start with this sort of thing. Item is some person. Okay. Then we ask for their state chart. Now we've got a reference to a state chart. That's what this is. And then we ask, hey, state chart, is this certain state active? Yes or no? So you read it from kind of the inside out. You read it from left to right. And so you start here, and you go to here. The A.get connected agent, it's calling, hey. So A is a reference to somebody. John. It's a reference to John. And we ask get connected agent number 3. Returns a reference to the agent number 3 to whom they're connected. Actually, it starts at 0. 0, 1, 2, 3. So it's actually the 4th agent. So you give it 3, it gives us back a reference to that. And then we say, hey, give me your name. And it says, oh, and that reference is Mary. It's now to Mary. So she gives us her name, and we ask what's the length of that name. Each of these is returning a reference to an object. This is a reference to an object. We get the connected agent. That's a reference to Mary now. Now we ask for her name. That's a reference to a string. Now we ask for its length. That's finally a value, 5. Or finally a numeric value, 5. They're routinely strung together like this. I like to keep my expressions small. This is getting near the limit of my tolerance of what I like to show to people, but we do this quite a bit in AnyLogic. You need at least a couple things here to sort of string them together. A much nicer way to do this would be to have item.isInfective, and that's a function you define in person that says, am I infected or not? And then you don't have to worry about what the name of the state is and so on. You just say, hey, are you infective? And it said, I am infective. And then you could change the state chart internally. All you'd have to do is change that one method. You wouldn't have to go fix it up in all these different places all throughout your model. You just change it one place, boom, done. Off to the races. Instead, here you have to change it a couple places if you change the things in your state chart. So in general, functions are cleaner, but we use these often. So any questions you want to ask about like making sense of something like this? When you see item.infection state chart that is state active, are you feeling comfort with that? Or are you exhibiting profound discomfort?
Just a quick example. So if you put item that is infected, and that's a function that you find in the agent.
Yeah.
So in the agent, the function would be this dot infection state chart dot is state active. I mean, that would be
in the function. And what it would mean, Sarah, is that you could call that function from many, many places in your model whenever you needed to know is someone infective. Say, remember we defined these various statistics this morning, and they were kind of variants on each other, just based on different subconditions, different conditions, whether someone is infective or susceptible. So often we're using the same basic logic, the same basic situation, the same basic condition in many places, and rather than repeating it in all its gore, all the gory details, if you just had a function that gave it a nice name, like is state active, it would be more transparent. You see, item.isStateActive, we read that, we know immediately what it means, and we call that many places. And then if we changed our state chart, we broke infective state up into two states, one for more severely infective, say an acute HIV, and one for a more chronic, long-term HIV situation, because we want to capture differential infectivity, or maybe we break it up to 10 different levels. If we were to do that, we wouldn't have to change anything here. We would just change that one function. Then that function we defined to not only have this, it would say, is this state active, or this other state, or this other state, or this other state, and all the rest of the model would stay the same. Does that make sense? So in general, we have these expressions, but we try to avoid really long expressions, particularly those that are repeated a lot. We try to substitute them with something that's clearer, something that has a nice name, something whose intention is clear. Because you look at this, it takes an experienced AnyLogic user, a few seconds, or at least a couple of seconds to kind of parse, okay, so we're basically testing if they're infective in terms of their infection state chart. It just takes a bit of time to understand it. Okay, right, variable declarations. We declared a variable, and variables are names are nice, convenient names for values. Okay, that's what they are. They're names for values, and they're associated with a location that we can change them, but often we don't change them. We just give it a nice name for a value. So let's go take a look at this, ladies and gentlemen. We saw this earlier, and I'd like to remind you of this. Here, birth. So here we have a baby born. There's a baby born, okay? And this add population, we're calling off to it. It returns what? It returns a value. What is that value? It's a reference to a person. Who is this person? It's the newborn baby. That's to whom it's a reference. It's a reference to the newborn baby. And we give that reference a nice name. We call it baby. So we have references baby to this new baby. We give it a nice name so we can refer to it. We could say, hey baby, set your location. Maybe set your name. Maybe set your characteristics. Maybe determine whether there's been vertical transmission of some infection. Maybe to set their aspects of their immediate context. So this is just a name for that value. We give it a nice name so we can refer to it, and we give it a so-called type. We say this baby is a person, because then it knows, because it's a person, we can call set XY in it. Because it's a person, we could ask for, about its infection state chart or what have you. So we give it a name for this reference. Does that make sense? Okay. So values we often give names for, and we use these variables for them. Okay? And then variables are associated with these so-called types: double, int, Boolean, string. Okay? And we declare a variable, person, baby, equals such and such. We indicate its name. In Java, the value associated with a variable can change over time. You could assign different values to variables, but often in AnyLogic, sometimes in AnyLogic, you just don't have to do that. So let's go take a look at this. So let's go take a look at person, for example. Person here. And here in person, we have, let's take a look at mother. Mother is a parameter, and it's associated with a type. Okay, there's a type for it. This is a type. It's the values it can hold are drawn from the set of all possible persons. It can hold a reference to a person, is what this is saying. And so it delineates what it can legitimately hold. By contrast, if we had income, it could hold a double precision value. Sex can hold a value drawn from the set of all sexes. So we associate these things with particular types. And we use this term variable for this. It's a term in Java. And we speak about different types of variables, and I'm not going to go into that a lot. But basically, there's variables that can live in so-called objects like person, like their sex, their age, their income, their ethnicity. Those are types of variables. We call them in AnyLogic parameters. We give them a special name and special significance. As far as Java is concerned, they're a bunch of variables. There's a bunch of variables there. That's it. Okay. So behind the scenes, if we go look at our Java code, take a look at that. Take a look at that. Here, behind the scenes, sex. Well, we saw it before. I don't know if any of you remember. You may not want to remember. You may have been perhaps even frightened by it. But here's person. There it is. Look, it's declaring it as a variable. Okay. Every person is associated with a sex. Okay. This is just a different type of variable. Okay. And we often give names to these things. So the example models from AnyLogic are chock-a-block full of sort of names for these sort of things for certain of those models. And the models I've provided you will often have them. And so if you have Java code, generally you give these short names to things. So we'll use X for our current location. So we'll call our getX, which gets our current location. We'll be seeing that tomorrow. And we call it X for now. We just use it as a nice shorthand for our current X location, and Y for our current Y location. Give it a nice little name so that we don't have to refer to this.getX every time, or getX. Does that make sense? Okay. Okay. I'm not going to go. I don't think this is essential for your learning. I could give you a long discourse on it, but I'm trying to concentrate on things that are really valuable for learning AnyLogic, and time is limited. Okay, you saw today the sort of A++, and that is not a superior grade. That's not a, it doesn't denote exceptional performance. Instead, it's indicative of a situation where we're getting the value. So we're getting a value. Maybe A has 3. And then we say we want to use that value. Use it in an expression. Use it in like add population. Remember this? Like let's go to our model that we added today. And let's go take a look at when someone gave birth. Here we go. Here's the birth event. And you'll notice that when we did this birth event, take a look at this. Boom, boom. See this next ID? Oh, it's just out of range here. There we go. See this? See that? I don't like writing that, but I did, because it's the most pragmatic and cleanest way to do it given what I've showed you. And I didn't want to put in a lot of extra mechanism. There's cleaner ways, but they require some extra mechanism. Here, I'm taking the current value of next ID in main. Next ID is some variable in main that's like a ticker tape thing. It keeps them going up. We take one, it's up to the next value. It's just like going into the lab testing things here in the city. I got to get my blood drawn. I go and I take a number and I sit down, right? And when I take that number, out comes the next number. The next number is the next number waiting. So I grab the number. I get my number. This is my current number. The value of this is my current number. But it goes and in the process of giving it to me, it automatically ups it. It ups it for the next person. So the next person will get the number one higher. So it's kind of like, you take it and the next one is ready. It's kind of like having a set of cups vertically, and you take the top cup and the next one's just ready for the next person. You take this one, the number is one higher now. As just after it increments it. It's actually, I don't want to confuse you folks, but it's actually different than doing plus plus before this whole thing, which would mean increment it first and then give it to me. Here, you give me the current value and then you make it one bigger as a result. Does that make sense?
So is the value that you get the one that's
the current value? No, before the increment.
So that the next person will get that.
That's correct. That's correct. It's like they hand you a Social Security number and they say, oh, the next one we'll be giving out is this 1+1. Does that make sense?
Yeah.
So that's all that means. It's sort of, they get ready for the next one to be given out will be one bigger than it was the one that I got. Let's suppose this starts at 0, and we're dealing with the first person being added to the model. They're going to get 0. But as soon as they get given, in the process of giving it, it's turned into 1. So they're given 0, but immediately now it's 1. So if another person wants 1 immediately, they'll give out 1, and that will make it 2, and it'll give out 2. Does that make sense? Okay.
Plus 1? What's the difference?
Okay, big difference, actually, big difference. So this actually changes the value of this thing. It changes it. So if I did +1, like that, if I said +1 here, it wouldn't actually change this next ID. It wouldn't change the value of next ID. It would just add 1 to it. It would always be the same. It would always be 0, and then it would add 1 to it. It'll give me 1, but the value of next ID would remain 0, and so the next person will get 1 as well. Does that make sense? Yeah. Okay. So the ++ is used to make it larger. That was that whole finesse associated with the thing I did earlier with the handing out these distinct ID numbers. Make sense?
But so that doesn't so much have to do with the number that I get.
No.
The number that will be contained.
Precisely. It has nothing to do with the number you're getting. This is.
But all the other
things. These are.
All what you're gonna get.
Yeah, and this thing is what I'm getting, the current value. It's getting it ready for the next person.
But isn't that kind of like what Applied Network sort of does?
Sort
of like saying we did something, now reset it to.
Yeah, and it's true that we could go, instead of doing it this way, we could call here a thing that says increment number, the next number or something. This just does it in a single place.
So if you just had next ID
and
didn't have the ++?
Yes. If you just did this, then everyone would be given the same ID. Each baby will be born with ID number 35.
The next ID itself isn't a function, it's just a value.
That's right. Yeah. Next ID is not a function, it's just some value. Does that make sense? Okay. Yeah. I know, it takes a little bit of time. Okay. I don't know how much I need to go into this. You can have these sort of values, a times equals to 2. This is just like writing a equals a times 2. A divided by 3 is like writing a equals a divided by 3. It's just a convenient way of sort of saying the thing on the left is the same as the thing being multiplied by this thing on the right. It's a shorthand way of indicating it's this thing that's being set to this thing plus, say, 2 or times 2.
Like Hewlett Packard, you see?
No, there we would do A2 times or something like that. But it's a convenient way of sort of, instead of writing this as kind of wordy and you kind of got to look on both sides, is it the same thing? And you put it all in one place. Boom. That can be a little bit, in terminology I've adopted from my younger students, can be sweet. Yeah, it's sometimes it's just sort of nice. So take this. So here we're doubling the income of our second, third, 0, 1, 2, third connected neighbor, sort of the neighbor to whom we're connected. We're doubling their income. Okay. Okay. Now, this is the thing I want to leave you with. This is the thing with which I want to leave you. Now, hopefully this won't be because I think you all run out of here having seen this. Suppose we have a reference to a person. The person is John. Reference to John. And we have some reference called M to another person. Call it Mary. It's a person in the population. Here we're saying John's. So this is a reference to John. Happens to be called A. Just a name for that reference. And we say a.mother. So John's mother equals M, which is referring to Mary. And then suppose we were to say a.mother, John's mother is this third person, 0, 1, 2, in the population, okay? 0, 1, 2, hence third. So here, now John, for his mother, is pointing to a different person, but Mary is unaffected. So here's, oh gosh, this is, what a weird thing. Sorry, let me correct this. This begs misinterpretation. What a horrible thing. This is female because we're setting it to be the mother. Okay, it's female. Thank you. There we go. Rightly corrected. Okay. So A is referring to John. This is John here on the left. So it's referring to John. John has an age. Maybe he's male, and he is. Oh gosh. Sorry, it's male. I was actually correct. Is male is the name of the field, and it's a Boolean, and it's false. Okay, that's fine. So the mother is not male. Good. That's good. Okay, so here's John. John has characteristics. One of the characteristics is his mother. And M is referring to Mary, who's his mother. Oh, well, to Mary, this person Mary. And now we're saying a.mother M. In other words, we're setting this so-called field, this variable within him. We call it a field sometimes. The variable within him to refer to the mother. Now, John is known to have this mother, Mary. Does that make sense? Yeah. Say a.mother equals M. So now his mother is referring to this. Okay? Are people comfortable with that? Now watch this. What happens now, can you tell me, if we say a.mother equals get main of population 2? So I'll give you a thing. So, I'm sorry, that was a.main, isn't it? No, this dot get main. So here I have this, and this, I don't know what it is. It's another person. Their main refers to this main class. This is main class. This is the main, and it's all these things in it, including a population. And 0, 1, 2, this is the third person in the population. Population member 0, 1, 2. Okay, that's this person there. Can't believe you people are listening. This is great. This is great. My colleagues wouldn't believe it. They'd say, like, no way. No way. Okay. I'm grateful here. Okay, let's have some suspense, though. So what's going to happen if we say this thing? If we say a.mother equals this dot get main population 2, what's going to happen here? How is the diagram going to change? If we say a.mother equals this dot main dot population, that's pointing to this number 2. It's this one here.
So that one is going to have those characteristics.
It's not necessarily M.
Okay, it's not necessarily M. So what's going to change here?
Where that pointer's going to. It's going to go potentially another.
It's going to point down to here. Does anything happen to this thing?
No.
No, it does. It's unaffected. It's unaffected. Now John is saying his mother is this other person, But this person, is still Mary. She's still Mary. And she might not be happy about no longer being declared John's mother, but maybe she is happy. Who knows?
I don't know, an error in the vital statistics.
Yeah, exactly. So correction of some birth record, right? Okay, now that John is referring to this person is unaffected. They're still referred to by this thing M. They still have a reference to them. Okay?
They may be irritated.
Maybe irritated, but maybe we should make it red or something. But they're unaffected by that. So in AnyLogic in Java, this is what's going on. And ladies and gentlemen, this will explain maybe one thing I said earlier today. Do you remember? Perhaps you were overwhelmed at the time. Hopefully not by sort of, perhaps overwhelmed by delight, or overwhelmed by horror. But you may have noticed that at one point I ran this model with a large population, and I went in and I said, oh, look, this person's mother is population number minus one rather. Do you remember that? It was population member minus one. That's someone who's no longer in this population anymore. Maybe they're like this person. But we still have a reference to them, so all their information is still around. They just don't happen to be listed in the population anymore. They're not population member 0, 1, 2. They're no longer in the population. They were removed from the population, presumably because they died. But we still have a reference to them. So we have all the information about them still. All that information is retained. And this is a little bit of a technical point, but it's sometimes important to realize. As long as we have a reference to them, all that information stays around. Java doesn't actually get rid of this information, mess it up, dump it out, change it in any sort of way, recycle it until we lose a reference to them. So as long as we have that reference, all this information is accessible to us. They just won't have a dignified name like population member 3 or population member 200. They'll just have, and it calls them population member minus 1. And lots of people can be given that moniker. It's just referring to people who are no longer referred to down here in the population. Yeah.
So that means you can't call it uniquely anymore. You have to call them by variable, by the dimension subset, whatever.
Well, that's why we gave them an ID. We give them this ID. We can give them a manual ID. Yeah. But one thing important, Illy, is that if a person gets removed from the population, let's suppose this person got removed from the population, this population member 2, all the others would shift down. They'll actually shift down. It's just like waiting in line. Again, you're third in line, now you're second in line, now you're first in line. You don't want to use your position in line to permanently identify you. Oh, you mean Chris? He's the 10th in line for the waiting for this for the bus or something. That's not going to be a persistent identifier. It's not going to be fruitful as a long-term designation.
Just like you removed the row kind of thing. You took it
Yeah.
out and you put it somewhere else.
Yeah, it's kind of
-1 something.
right, and like all the rest get shifted down. Yeah, it's like deleting the row in the spreadsheet.
Then you have -1. You have all these different people.
All these different people are called -1. They're all called -1.
Exactly identifying if you can't remove, otherwise that information is correct.
Oh, no. As long as you have any reference to them, like as long as, remember today we introduced a mother field in each person. They referred to their mother. As long as somebody in the population refers to them, as long as there's some reference to them, their information will be maintained.
So that link that you had before, the first example, that you still have that link, that connection of that person, of that John.
Well, okay, this thing, you mean that link? Okay, this link is changed to this, but because there's still this M referring to her information is still going to be maintained. If there's no other reference to her, if she were kind of forgotten in the sense that nothing's referring to her, then it's actually going to go clean up her information and say, you don't need this anymore, okay? So
if you were doing
10 minutes is the last show.
Yeah.
Okay, so if you're doing like a life course.
Right.
And it matters the circumstances under which you were born,
Right.
vulnerable mother, whatever. Okay.
Right.
You could always refer back to that, even if the mother is deceased.
That's correct.
And so you could always know what
Yeah.
their starting point is.
Yes, that's correct. That's correct. So it is possible to refer back to that information even after the person's been removed from the population. Now this is a Java thing. It's a nice feature of Java. As long as there's any need to refer to this, as long as anyone has a reference to it, it's guaranteed to be preserved. And a lot of other systems, that's not the case. The information will be readily recycled. And it's a difference between programming languages, whether you do this manually or not. And it's a lot more painful if you have to explicitly say recycle this. But Java takes care of that automatically. And it has very sophisticated ways of doing that, of figuring out, is there a reference to it somewhere? Is somebody referring to it somewhere? Okay? So that makes it very easy to trace these multi-generational lineages in the model. Even for people who are long deceased in the population, you can trace family lineages. And when we were at UCLA, there was a grad student, who wanted to do exactly that. And it's almost a piece of cake, because you could just go back, tracing people's father and mother in the population. And
San Francisco is multi-generational birth and family data.
Yeah.
For a group they followed for a long time.
Right.
So
Right.
you can go back several generations in that.
Yeah, exactly. So that's the sort of thing you could do synthetically in the model. Okay? So time is short. The shuttle will be arriving here. I'm just amazed and grateful for your attention. Tomorrow we're going to be seeing statements and seeing things like how those for statements work and if statements, and seeing how we can do and how we can make sense of some of the code that's actually generated automatically. And you can actually understand why, for example, things are called item, etc. Okay? So you'll get to see how you can write these little statements to do longer pieces of functionality. Okay? So thank you very much.
By the way, Nick,
Yeah.
AnyLogic 7 requires